Alright, so section 3.2, continuing with the theme of probability. Section 3.2 is on something called conditional probability. And conditional probability basically means the probability that something will happen given some other condition. Okay, so the goals for this section is we want to find out how to apply that to some specific problems. Also want to talk about something called independent versus dependent events. Dependent events means two events where what happens depends on something else that happened. And then the last thing we'll talk about is something called the multiplication rule, how you can find probability of multiple events, two or more events. Okay, so the first thing we want to talk about, just to define conditional probability. Okay, conditional probability, and you can kind of tell from the word conditional. Conditional means what is the probability that something will happen given that something else has already happened. Okay, and the way that you can read this, you can see this symbol right here. The way that you can read this is the probability that event B would happen given, that little vertical line right there is a math shortcut symbol for saying given the probability that event A happened. Okay, and this is literally what that means. It's a faster way of saying the probability of event B happening given that event A happened. Just some notation to get used to. So here's an example. It says two cards are selected from a deck of 52 cards. Find the probability that the second one is a queen given that the first is a king. So here is how we write that. Find the probability of a queen given, again that slash means given that the first is a king. And this is important, the king is not being put back. So you're taking a card out but you're not replacing it. Okay, well let's think about, first of all let's think about the probability of this, the probability of picking a queen out of the deck. Probability is what we want to happen. Okay, what we want to happen over what could happen. Okay, well what could happen when you pick cards out of a deck? You could pick 52 cards. And what do we want to happen? We want to pick one of the four queens. So there is a 4 in 52 chance. There's a 4 in 52 chance normally that we would pick a queen out of the deck. Okay, but this is a little bit different because this is saying we want to find the chance that we're picking a queen given that we already picked a card out that was a king. Okay, so the difference is this, the probability of picking a queen given that we picked a king. Well, if we picked a king, now there's not 52 cards, there's only 51 cards. And that means 4 out of those 51 cards are queens. So that is the answer to the question. Okay, you have to keep in mind that because this first event has taken place, we no longer have the same probability because we're not picking out of 52, we're picking out of 51 this time. Alright, so I want to see if we can do another example. This is called a two-way table, and these types of questions are popular on ACTs and SATs. So I always encourage you to see if you can pause the video and try this one on your own before we go through it together. So you have this table, it's showing the results of a study in which researchers have comparing a certain child's IQ with whether or not they have a certain gene in their DNA or not. Find the probability that a child has a high IQ given that they have the gene. So this is important. We're only going to be looking at this right here. We're only going to be looking at children that have the gene, and that is this column right here. So we're only looking at those 72 children because we're given that those are the people that we're dealing with. So our probability is going to be out of 72. Whenever you're doing these problems, always start by looking what they give you because that will narrow down the possibilities. So given that we're one of these 72, given that we're one of the children that has the gene, what's the chance that we have somebody with a high IQ? And you can see there's 33 of those people. So there's a 33 in 72 chance of that happening. Okay, one more I want to give you here, and this is for you to try. What's the probability of somebody having the gene given that they have a high IQ? This is a slightly different problem, right? I'm wording this differently. It's almost like you swap those. So probability of having the gene given that we have a high IQ. Alright, so if we are given that we have a high IQ, that means we're only dealing with these 52 people right here. Because there's 52 total people that have a high IQ. What's the chance out of those 52 that we have the gene? There's a 33 in 52 chance of that happening.